Hi everyone. In this video, I'm going to show you a new feature coming with the GlueMesh Enterprise, which is focusing on airback and especially how you can manage airback across multiple clusters where you have service mesh deployed. So before we start, let's go through different options you have when it comes to airback on Kubernetes, and then on Istio, and then what are the challenges when we start to deploy Istio on multiple clusters. So first of all, on the Kubernetes side, you're probably all aware of the way airback works, where you can create these roles and cluster roles and role binding and cluster role binding. Very common use case for that is when you want to share the same Kubernetes cluster with multiple teams. You generally create a role for each team, so that basically each team gets its own namespace, and they become like namespace admin. So there is no impact on when one team does on another one. So you can create these roles like that, and you say, okay, that's a role that gives permissions on all the API groups that are part of the core Kubernetes, and then you define the resources. So if it's a namespace admin, for example, it would be any resource and any verb in the namespace. And then you do like a role binding where you attribute the namespace admin role to a user or a group of users. So that's the way you generally handle airback in Kubernetes. When you start to use Istio, then you can start to create additional objects that are not part of the core Kubernetes, what we call custom resource definitions. You can create authorization policies, but authorization policy has nothing to do with airback. It's just like a way for you to say, okay, this service is allowed to talk to this service. It doesn't allow you to specify that user can create this authorization policy. And authorization policy is just one example, but you have also virtual services, like these are the ones for security, and then they have the one for traffic management. So basically, if you want to determine who can create these objects, then you need to use the traditional Kubernetes airback. So here, instead of just saying like the API group is double quote, like, which means like any core API group, you would do like comma and then the API group of these different objects. For example, you could do API group security.istio.io v1 beta 1, which is the one where you have this different security object, and you would do the same here. If it comes to virtual services, there will be networking.istio.io. So you could create different rules here with these corresponding API groups and different resources, and you could say, okay, this user can create this kind of object there. But you cannot go really fine-grained. You can just tell if they can create or not these objects, but you cannot define what information they put in these objects. So if someone creates a virtual service and then decide to route that to a specific service, you cannot determine or you cannot define airback rules that will prevent that person to do that. It's either you let him create these virtual services or you don't allow him to create this virtual service. So that's one limitation. And then when you start to adopt like multi-cluster service mesh, that becomes even more challenging. So let's take this example here. So we have like two clusters, Istio deployed on both clusters, and we want basically this service to be able to talk to this service. So to do that, normally you need to create like a lot of different objects, like a virtual service with all these parameters like a destination role here for all the subset that you define in the virtual service, a service entry for if you have like multi-cluster rules like you see here. I want to target another cluster, so I need to tell Istio how to contact the service on this cluster. So you need to give like the IP of the Istio ingress gateway and the port and so on, and then some other object you create on the other cluster. So as you can imagine, first of all, it's quite complex, and it would be very difficult to define airbag rules for that. You would have to create like a lot of roles and role bindings on both clusters, and still you will need to create all these objects. So that's where Glue Mesh is very interested. So Glue Mesh, you deploy it either in one of the cluster or even in a third cluster where you just have management software running here. And instead of having to define all these complex objects, you just create very simple abstractions like this traffic policy here. You see, very simple to read. When I have a request going to the review service on cluster 1, then I want to do traffic shift and send 75% in the other cluster on version 3, and then 15% locally on version 1 and 10% locally on version 2. So first benefit of Glue Mesh, it allows you to just express what you want to do with a very simple policy that we call a traffic policy, and then it creates all the complex objects for you, and it maintains them, so it makes your life a lot easier. Second benefits, as soon as you have this kind of rules in place, you also want to define what we call Istio authorization policy, to make sure like you have some control on which service can talk to which service. And that's what you do with what we call authorization policies in Istio. But again, that's really a concept that has been built for single cluster. And when it comes to multi-cluster, you need an abstraction. And that's what, again, Glue Mesh is providing. So you get this abstraction. First of all, you create what we call a virtual mesh that can be composed of multiple clusters where Istio is deployed. And then you enable global access policy, which means that by default everything is forbidden, so no services can talk together. And then you build your access policy. So it's another abstraction. We discussed about the traffic policy before. Here it's what we call access policy. So here you have like this abstraction where you can say, okay, this service account on this cluster can send requests to the services that match the destination selector. And the service account here is unique between clusters if you deploy everything correctly and you have different trust domains and so on. I won't go through the details, but basically these policies are global policies, and that's what's really important. So we have this traffic policy and we have these access policies, so that's good. We can now easily manage these cross-cluster communications. But what about airbag? Because as I said, these abstractions will then create a lot of different Istio objects, and even with a single cluster Istio deployment, we see that we don't get the granularity we need. So again, another thing that's coming with Glue Mesh and that we are focusing on in this video is this airbag capability, where you'll be able to define who can create what kind of policy. So this user can create a traffic policy, but only that way. This user can create an access policy, but only that way. So what you see here, first of all, let's take a look at our environment. So we have this nice UI that comes with Glue Mesh Enterprise. And in this UI, what you see is that we have like a virtual mesh that is composed of two service mesh clusters. You see here cluster 1 and cluster 2 where I have Istio deployed on both of them. And you can see we automatically detect like traffic targets and workloads that are running there. You can take a look at the different policies. You see here we have some access policies like we described before. You see like the product page policy that allows the product page to communicate with the details and review microservices on both clusters, for example. So this UI is very nice because it shows you when you build a policy what are the services that are impacted by this policy. And the second step is about airbag. So now how I make sure that people will not be able to create like any policies they want. I want to have some control on that. So let's say now I have enabled this airbag capability and someone wants to create like a traffic policy, the one that I described before. So someone log in here, is an admin of the Kubernetes cluster here, and he wants to create this object. And you see he cannot because I enable airbag, and this user doesn't have any permission on this airbag. So what we have in this in GlueMesh in terms of airbag is that by default we have this admin role, and you see it's very similar to in terms of naming to the Kubernetes airbag. You have roles and roles bindings, but you see the API version here is different, and you see we have a lot of granularity here. So we can say this admin can do everything. You see a lot of stars everywhere, a lot of wildcards, but that gives you an idea about the granularity. You can define what kind of policy you can create. So if you remove these access policies completely here, then this role doesn't allow the user associated to the role to create any access policy at all. The same if you remove that or something else. And in this case, with the admin role, someone can create like access policies on any that can target any cluster, any namespace, any service account in any namespace, and so on. So if I want the Kubernetes admin of this cluster where GlueMesh is deployed to be able to create these different policies, what I need is a binding. So I will go and create that. Like it's a role binding here, and you see I will give this admin role. I will grant admin role to the Kubernetes admin user. So I'm going to do that now. And if I try to create my traffic policy again, you see that works. It can go through, you know. And if I go in the UI here, I see my traffic policy is there, and you see easily. You see like the weights that I described before. And what's interesting as well is that in the GlueMesh UI, I can go here and click on role-based access, and I can see this admin role policy as I described before. Basically it allows everything, and I can also see the binding. So I can see here that I have this Kubernetes admin that has this admin role. So it's very nice for control, making sure that you can see very easily if there was, you know, no mistake made, you know, someone had too many permissions and stuff like that. So that's like an admin role. Now let's say, and we discussed about this use case, which is very common. Like I want to have like a namespace admin. I want to segregate my cluster with namespaces. How does it apply in a multi-cluster service mesh? Basically, you could do the same. You would just simply modify this admin role and create a new role based on that, where you just specify the namespace. So now a user that has this role can create like traffic policies and access policies and things like that, but that only targets his namespace. So it will be able to allow cross-cluster communication between services, but only in the namespace that he owns on both clusters, which is very, very useful and very common use case, as I said. So let's just create this new role, which is like a kind of a namespace admin role, and let's do like a binding again. So I'm going to bind this role the same like I did before. If you look at the role binding here, you see I just use the same name, so I will just like erase it. I will update it. So instead of being like an admin of the full stack, it will be just you will just have this role here. So I'm going to apply that now, and now that I am like having this namespace admin role, I can try to create here, and you see like I am an admin of the default namespace. I don't think I mentioned that, so it's quite important. And here, as an admin of the default namespace, I want to create a traffic policy that will impact the traffic on the NS1 namespace. So let's try to do that. And as you can imagine, it's not allowed. So that's really what I wanted to get at the end. You know, I wanted to make sure that I am not, you know, because now I am just like a default namespace admin, so I can only create object on the default namespace. Now I cannot impact the other namespaces. Obviously, that's just like a simple example, and with the granularity that you've seen when we create these different roles, you can do much more. I mean, you could have use cases where some people can only define access policies. They are like the part of the security team, and they focus on just that part, you know, the access policy, determining which service can talk to which service. Some other people could perhaps be allowed to do anything they want, but only in one cluster. They are not allowed to do multi-cluster things. Perhaps they are part of a dev team. You give them resources in the local cluster, but the remote cluster is only like for production. I don't know. Like that's another use case. You could also have roles where you only allow like a little bit like the namespace admin, but basically you can only create roles that impact the target services, not the source services. You get a lot of granularity. So I hope that it was clear and it was useful. I really encourage you to try out GlueMesh and let us know what you think about it. Thank you.